Well, in this lesson, I will now show you how to automate the creation of snapshots for your EBS volumes. Although we have already reviewed the manual process, automation proves to be a more efficient option. It is important to remember that there are multiple methods to accomplish this. For example, you can use services such as AWS Backup and Amazon Data Lifecycle Manager. These services are just a few of the various alternatives available to automate this process. So, you can then use Amazon Data Lifecycle Manager or DLM to automate the creation, retention, and deletion of EBS snapshots and EBS back AMS, all at no additional cost. Data Lifecycle Manager is an EBS centralized data protection service. It is a way to automate backups of data stored on Amazon EBS volumes. Let's look at some use cases that illustrate when Data Lifecycle Manager is an appropriate data protection control mechanism. If you have EBS volumes on which data resides, you can create an automated snapshot protection policy using DLM. If you use Amazon Machine Images or AMIS, which are backed by EBS volumes, you can create an automated protection policy. This can be especially useful if you use launch templates for individually C2 instances. Also, it is useful when maintaining AMIS that support auto-scaling startup configurations. Also, if you use best practices to protect your data in a separate Amazon account, you can automate data protection between accounts. It's worth reiterating that you can use Data Lifecycle Manager to implement your data protection scheme at no cost. Of course, you will pay for the underlying storage consumed by the snapshots. There are still other use cases, but with this basic understanding of what Data Lifecycle Manager can do, let's look at a real-world scenario. Let's say we have a server running in the US West 2 region of Oregon. This is a transactional server, and I want to protect it against hourly data loss. My recovery time objective, that is, RDO and recovery point objectives, RPO, dictate that I need to be able to go back in time 3 hours. Therefore, I can configure a policy that will take a snapshot of the instance every hour for 3 hours continuously. To identify the instances to which I want this policy to apply, I create a new tag called DLM. When it has a value of true, this policy will take effect and the instance will be backed up. Note that this includes the EBS brute volume for the instance, as well as any other attached EBS volumes. So, in the first hour, snapshots will be taken of the volumes underlying the instance. Since I am protecting against a regional failure, I have configured the policy to replicate these snapshots to US East 2 in Ohio. When the second hour arrives, another snapshot is taken and replicated. At the third hour, another snapshot is taken and replicated. Remember that each incremental snapshot only consumes the modified blocks from a storage perspective. At the fourth hour, new snapshots are created and replicated. However, since I configured the policy to retain 3 hours of data, the first hour snapshots are automatically deleted. So, with this information in mind, let's put it into practice. Okay, here I am in Data Lifecycle Manager. We can get to it from the EC2 service and then in the Elastic Block Store or EBS category. In this demo, we're going to create a policy that will protect specific EC2 instances every hour on a rolling 4-hour basis. If I go to Instances, I can see the EC2 instances. In this case, I'm interested in protecting my Linux instance. When we select it, let's take a quick look at the storage associated with it. Here we can see that we have 2 volumes. The first, an 8 GB brute volume, and the secondary data volume, which is 20 GB. Looking at the labels associated with this instance, I see that it has a label with the name EC2 Linux. So, I'm going to add a tag so that Data Lifecycle Manager knows that I want this instance to be backed up. So, I'm going to specify a key like DLM and a value of true. Save. And if I select my Linux instance again and go to the Tags tab, I can see that it has been added. With this setup, let's now create a lifecycle policy from Data Lifecycle Manager. I will leave the EBS snapshot policy type selected and click Next. On this screen is where I choose the resources to back up using the policy that we are going to configure. So, from a resource standpoint, I want to make sure that my entire instance is protected and not just individual volumes. So, I select the instance option. Now, under Target Resource Tags, I select my DLM tag with the value True and click Add. With this, I want DLM to use it to identify the instances that will be backed up. In this case, since I already created a DLM tag, it appears here in the list. In the description text box, I write hourly for 4 hours, indicating that this will back up my instance continuously. Below an IAM role, I leave the default as it is sufficient for this demonstration. Further down in tags, to facilitate the administration and categorization of the policies that I create, I will add a tag with a key name, DLM, and EC2 value. Further down in policy status, I will leave it enabled. Under optional parameters, I can check these boxes if I want to exclude specific volumes from those instances to be backed up. I'm not going to check it. I'll click Next. And here we get to the most important thing, which is the scheduling details for the policy I'm creating. So, for the name of the program, I am simply going to call it Backup EC2. Examining the frequency drop-down menu, you can see that it is possible to create any schedule you can imagine. In my case, I want the frequency to be daily, and I want it to run every hour. Then, I can specify a time when this policy will take effect. The default value is 9 o'clock UTC. That time works for me, so I will leave it unchanged. In the retention type, I can specify a snapshot count or based on the age of a snapshot. For age-based retention, the interval you can set here is from 1 day to 100 years. Once the retention period of each snapshot or on the elapses, it is deleted. In this case, I simply want a snapshot count to be maintained. For count-based retention, the range should be 1 to 1,000. Once the maximum count is reached, the oldest snapshot or AMI is deleted when a new one is created. So, I will specify the number of snapshots to retain. In this case, it will be 3. It is only 3 snapshots that I will retain. When a 4th snapshot is created, the first one created, which would already be the oldest, will be deleted because the maximum number has been reached, which would be 3. Further down in the tagging section, I can specify whether or not I want the source volume tags to persist. In this case, I do. Note that the additional tags section gives me the opportunity to create any tagging scheme I want to identify backups. Below, I can trigger pre- and post scripts on the target instances before or after the snapshot creation has started. In this case, I don't want to. In Fast Snapshot Restore, this is something I can enable if I need the snapshot to be instantly at performance parity with its source volume. That is, it allows me to restore a volume from a snapshot that is fully initialized at the time of its creation and instantly provides its full provisioned performance. Note that this feature has an additional cost that is billed on a permanent basis. So, this is not something you need for this demonstration. Further down in cross-region copy, I have the ability to create a copy in a different region. Of course, copying to a different region has an additional cost. However, since I am interested in protecting against the possibility of a region failure, that is a cost I want to incur. Therefore, in the target region, I will specify US West 2. Note that the granularity for copy retention is in days, weeks, months, or years. So, although the source copies will be created every hour, they will be retained in the target region for a day. Of course, you can play with these values here according to your policy. Finally, under cross-account sharing, we can check this box if we want to share those snapshots that will be created on this schedule with other AWS accounts. If so, I just need to add that account and place the account ID here. This is one of the best practices to protect your data in a separate AWS account. If a problem occurs with this account, I know that I have my snapshots replicated, not only in another region, but also in another AWS account. For now, that's not what I want here, so I cancel and disable this option. Then, having configured all this, I just click on Review Policy, and this shows me a summary of the policy. Notice that I can create up to 3 more schedules for this policy. Since this is not what I want to do, I go to the end and click Create Policy. And it is created. So, when this policy runs at the scheduled time, it will create a snapshot of my instances that has a tag as a key DLM. And when that snapshot is finished being created, you will see it here in the Snapshots section.